as Giacomo said, I'm in Singapore right now, so here is 10 a.m. I know for you is 10 p.m., so I will try to keep it condensed and short. And the topic, as Giacomo says, about prompt engineering, that first thing I want to say is not really engineering, so don't be scared. We will not see equation and crazy stuff. It's really more about communication, how we can ask to an LLM like the GPT, Gemini, Claude, whatever you use, how we can ask questions in a more effective way so that the answer we got is closer to what we wanted. A few disclaimers before starting. Number one is that prompt engineering is more an art than a science. So again, don't expect equation, don't expect theorems and this stuff. And also, you don't need to be an engineer to understand. The main point here is to be open-minded and also be willing to explore different ways to interact with this new technology that is already everywhere now. And also, another thing that I want to mention is that some of the techniques you will learn here may also help you to communicate better with people, right? Because when you are talking with an LLM, you're talking with a system that is trained mostly on content that was generated by people. So some of the ways that you can effectively engage with LLMs can translate back to how you interact with humans. This is the outline of the presentation. So first, why is prompt engineering so important? Then we will discuss the basics of LLM. And by the way, LLM, if you don't know, is large language models and some of the configuration of these systems. Then we go to the central part, that is the prompting techniques, specific ways that you can frame our input in such a way that the output we get from the LLM is more aligned with what we want, and then the summary of the talk. Now, if you see here in the title, instead of prompt engineering, I put communication in red. And the reason is what I shared earlier. There is an overlapping between the ways we communicate better with LLMs and the way we communicate with people. So some of the things you learn here is related to communication in general. And in this first section, what you're learning is the assumptions that we make when we communicate and the risks that are associated with that, some of the basic elements affecting the communication, and then some tips to improve clarity. And because I think that the best way to get something is to experience firsthand, I don't want to tell you why communication is important, but I want to experience with an exercise. So now we play a game, and the game is like that. You should be split in groups of 2 people and then assigned later to Zoom rooms. And each group is made by person A and person B. Okay? And in this first part of the exercise, person B will get a picture, a very simple picture that person A cannot see. Okay, so person B got a picture and A doesn't. Now, what person B must do is to describe only verbally to person A what is on the picture. And the task of person A is to draw it as close as possible to what B is sharing. Okay, so you have 7 minutes to do that. I repeat, person B got a picture and should describe only verbally to A what it is, and then A can draw it. You can draw it if you have a piece of paper and a pen, or you can use the link that was shared on the chat. And that's it. So this is the first activity, and then I guess that now you will be split and sorted in the rooms, and then we come back in, say, 7 minutes. Great. So welcome back. How was it?
Well,
Really present. Oh,
that's
someone is
pretty good.
sharing something.
Oh, yeah.
Oh, no.
Oh, that's nice. Oh, by the way, maybe I just shared for everyone the picture, right? So you can see this was the picture.
Oh.
So I see on the chat, I don't know who
Nice.
wrote that. Oh yeah, proudly. Yeah, that was pretty close. I think is a nice attempt. And I mean, I want to give a quick comment here before moving to the second part where you swap plays. So if you thought that you were lucky because you didn't have to draw, now you will have to draw. And I don't know if it was harder to draw or to explain, but you can see already from the chat that the pictures are representing that concept of house, sun, and tree, but they are not exactly the same, right? You can see differences. You can see the sun. One sun is smiling that I like, but it was not, right? Or maybe the tree is not exactly the same. In 7 minutes, I think you did probably better than the guys who work in the real setting. So I think is pretty good. But we can have the overall discussion at the end when you have the other person also drawing. So at this point, thank you for your draws. Then maybe you can have I don't know, can be part of the course as a memory for this. But I will move now to the next part. And in the next part, you are changing places. So now person A and B switch places. So read carefully the instruction. A now got 7 minutes to describe the picture to B. Okay, so A has 7 minutes to describe the picture to B, and B cannot look at the picture. And then the objective of B is similar, right? Is to draw as close as possible to what the picture is. So I think we can again switch to the rooms. I think everyone is back. And then, as I did for the previous one, I show you the picture for those who didn't see. That was it. Mm. Okay. So at this point, you have done this activity. You were describing a picture, drawing the picture, and I would like to know, I mean, I've seen already some of them, but how close or far were the picture? And actually, my question is, did you think before this activity that it would have been easier or harder to get something as close as possible to the picture? Because if you look at what you have done, some of them are closer, some of them are less close, but they are quite different from the original, right? And it was a fairly simple picture, like especially this one was simple. The other one maybe a little more complex, but didn't have the colors. So what do you think? Just want to get some feedback from you guys.
I feel like it was easier to describe than draw, personally.
Easier to describe. Question. Because this happened in the real setting. When I did that, right, in a room, then I put pens and pencils and highlighters and people can take. And then after they did the first one and they see that there is no color, nobody took highlighters to draw the second one. And then when they had to draw it, they didn't have the colors. So why is that important? Remember, I say something about assumptions. You have seen the first picture, and then you probably assume that there is no color in the second one as well. But it was not the case. Okay? And another question I have for you. Did you realize that in the second set of instruction, I never said that you can only communicate verbally? So you could even communicate non-verbally. If you see the difference between these, here I say only verbally, right, in the first task. But here, I drop that part. So technically, you could have even taken a picture with your phone and show to your friend, right? Or maybe use some other way. So these two examples, the color and the fact that I dropped that part in the instruction, is related to the assumption that we make, right? Because we see something and then we draw some conclusions. And this can affect the way we communicate. And if you look at the picture, many of them were, maybe I go to the chart again. For example, I see many people, they draw the table in the second one 3D, but it was a 2D, right? Some draw I know this, for some people it was harder to find the colors, but some of the circles were, like there was one case where the circle is empty. Okay, so the line is yellow or orange, but inside is empty. And in the first one as well, like you have sometimes the sun that is smiling, or you have the smoke that was not there. Or in one example, the sun was aligned on the right, but actually was in the center. So why are we doing this actually? You may be thinking, okay, how is this related to prompt engineering or to communication in general? And the thing is this, the main point I want you to bring home with this activity is that what you have in your mind when you communicate to others is not what the other people will get. But of course, when we communicate, we always assume that this is the case. We assume that when we explain something to someone, the other person should get exactly what we mean. But that's not the case. And why is not the case? Well, there are a few reasons that I want to quickly share with you. Number one is the misleading assumptions. I give you already a few examples, right? The color, or the fact that you expected maybe a table, right? When you say table in your mind, maybe was something 2D, but for the other person is 3D, right? And another point that is quite important is filtering. So this is more on the communication theory, that is this thing called meta model that was introduced by Virginia Satir, who was a family therapist. And then the main point here is that when we communicate, we use three types of action: deletion, distortion, and generalization. And this is what make what we have in our mind different from what the other person receives. So what is a deletion? For example, in the previous activity, did you say that the table and the monitor were aligned on the left side? Maybe you didn't. So this is a deletion because you dropped some information that was useful to recover the real picture, right? Distortion, I give you a very simple example. Imagine that I draw a mouse on the desk, right? So maybe you say a mouse, and maybe the other person is drawing not the device, but the animal. It may happen. I mean, it's unlikely because of the context, but it can still happen, right? So this is a distortion. And generalization, again, take the example of the picture. As I said, in the real setting, I've seen that because people saw that the first picture was black and white, they generalize and they assume that, well, the pictures in this activity are black and white. But then you got the color, the yellow. Okay. And then there are other reasons why what we have in mind is not exactly what the other person get. So the preferences, for example, or the belief or your past experience, right? Imagine that you saw a Ferrari and the only Ferrari that you saw was green. I'm inventing, I know it's unlikely, right? And then someone asks you to draw a Ferrari and then you draw it green, and the other person is, why is not red? Maybe because you only saw green Ferraris and the other person saw red Ferraris. So all these together, what we have in terms of beliefs, the preferences we have, the experience we got, and the fact that to process information, we need to delete, distort, and generalize, because we cannot save everything that we see. We need to compress somehow. This creates differences in communication. It creates a mismatch between what we want to communicate and what the other person, or in this case, LLM, understands. So this was the reason why I wanted you to go through this activity, because by looking at the difference between the real picture and what you draw, then you can appreciate these kind of concepts in practice. But that's all. This was the most interactive part of the lecture in terms of you doing something. So now you can relax. What to do then may be the question to mitigate these challenges. Number one is that clarity is the key. You need to be specific and reduce the assumption as much as possible. Okay? And the question you should ask yourself is, does the other person or LLM know exactly, this is the key point, exactly what I mean? When I say draw a table, what is a table for me? What is a table for the other person? Okay? And there is a sentence that is often used in communication to remember this concept, and the sentence is, the map is not the territory. So your own subjective view of reality is not the objective reality, and is different for everyone. Okay? So always remember when you communicate with an LLM, these points, because these may be the reason why you don't get the answer that you wanted. Okay, so what about prompt engineering now? So if communication, if communicating with a single person is challenging, then imagine how more challenging it is to discuss with an LLM. Why? Because an LLM is trained with a huge variety of content coming from different people and different contexts. So the map, the so-called map, is way wider than that of a single person. But there is a good news, and the good news is that with some prompt engineering techniques, you can instruct the LLM to behave like you want the LLM to behave. And this, of course, is much harder with people. You cannot tell people, hey, you should reply like this or like that. But with LLM, you can. So let's move to the second part now, that is some basics of LLM and some configuration that you can set in order to get different results. And the main 2 points here will be what is an LLM, okay? And then 3 main parameters that you may encounter when you work with them, that is temperature, top P, and top K. So what is an LLM? An LLM is a prediction engine. Okay, so this is very important. An LLM is not something that is there reasoning or solving problem. The main task of an LLM is to predict what to say next. And the way it works is that based on some input text that the LLM have seen so far, it will predict the next token, the next thing to say based on some probability. And this probability depends on the training. So in these examples, for example, you see that there is a sentence, the sky is, and the LLM must say, okay, what is next? And then in this example, you have a few words with different probability. So it's a log prob, but okay. And you see that the most likely is blue. So because the most likely is blue, then the LLM will complete the sentence with blue. The sky is blue. Okay? So remember this, an LLM is a prediction engine. This is very important because many people don't think that this is the main task of the LLM. So as I said, you select the next token based on probability, but then you have some degree of control over how this probability can be adjusted to have different output. And to do that, you use parameters like temperature, top P, and top K. So let's start with temperature. Temperature, in a way, is the degree of randomness in selecting the next token, and it's between 0 and 1. So a temperature for 0 means deterministic behavior. It means, if you go back to this example, what I say next is exactly the word with the highest probability, and that's it. If the temperature is 1, is a completely random behavior. It means that any token can be selected. And ChatGPT, last time I checked, the default value of this parameter temperature is 0.7. So you can imagine that for tasks where you need, instead of randomness, let's say creativity, you want a higher temperature. But for tasks where you want a deterministic behavior, maybe situations where you have only one possible answer, like a math problem, then maybe you want a lower temperature. What is top K then? Well, top K is another parameter that restricts the search for possible token to the top K based on probability. Okay, so the top 3, 4, whatever it is. And if you say K is equal to 1, again, you are having a deterministic behavior because you are saying the only choice you can make is the single token with the highest probability. And then you have top P that is a similar concept, only that is not looking at the discrete number of choices, but the cumulative probability. So if P0 means you can only take the highest probability, P1 it means you can take the full range. So now you have seen these three settings, and of course, to some extent, they can be combined. But my suggestion is if you want to experiment with that, take one, for example, temperature, and start to change it to see what is the different behavior. So again, for temperature, you may think that creative tasks set a higher value, deterministic tasks lower value. If you want a single answer, single correct answer, then T is equal to 0. Okay? So basically, in this second part, the main points are, number one, LLM is a prediction machine. The job of an LLM is to predict what to say next. And with these three parameters, top P, top K, and temperature, you can somehow control how the next thing to say is selected. But then you can be way more specific. And this is the topic of the next session. How can we use different techniques, prompting techniques, to get the result we got? And these prompting techniques basically means the way we formulate our question. And I will show you here a list of specific techniques and then some best practices. So let's start with the first one. This is called 0-1 few shot. 0 shot means I ask a question and that's it. I just ask a question. 1 or few shot means I want to ask a question, but I want to show to the LLM some examples. Okay, so here you have a prompt, right? I have a review of a movie and I ask the LLM to classify the review as positive, neutral, or negative. This is a 0 shot because that's just my question, right? This is the review, classify. So what will be, for example, a few shot example? It will be something where I show a review and then I show what is the classification. Maybe I show a review and I say, okay, this is negative. Then I show another one and I say, this is positive. And I show a few examples like that. And then eventually I show my review and I ask the LLM, okay, now I want you to give me the rate. So why is that important? Because LLM will see some examples of input output. So it will be easier to understand what I want. Remember, what we say before is that we need to be clear. We need to reduce as much as possible the ambiguity and the assumptions that we make. And the best way is to show some example to what we mean. Right? This is how we learn also many times. When we have a new task, someone is showing how to do, and then we learn by looking at these examples. And here we are doing a similar thing. In this case, just remember a very important point. If you have, like in this case, different possible outcomes like positive, neutral, negative, your example should touch the different classes. So don't just show positive examples. So this is called one if you have one example or few shots. And usually they suggest to give at least 3 or 4, but not too many. Okay, next one is called chain of thoughts. And by the way, some of these techniques may be more or less relevant with the evolution of the new version of the LLMs. Okay, maybe something is already integrated, but it's still worth trying. And chain of thought, in short, means when you ask a question, ask to the LLM to think step by step. Now you may be wondering, okay, but is this really making a big difference? Like I have a complex question and then I ask things step by step and then suddenly the result is better. Well, it can be. Let's look at this example here. Is a math question, right? Is when I was 3, my partner was 3 times my age. Now I'm 20. How old is my partner? So the answer will be, well, when I was 3, my partner was 9, right? So if there is a difference of 6 years, now I'm 20, then my partner should be 26. But the LLM is saying 63. Now, if you know what I shared earlier, you should not be surprised. Remember, the LLM job is not to reason. The LLM is to predict what to say next. So you should not be surprised that it can make mistake in mathematical questions. However, let's see what happens if we say think step by step. Now you see that the output is completely different. Because when you ask the LLM to think step by step, is splitting the complex task into shorter tasks, and the likelihood to make a mistake in each one of them is lower. So in other words, if you ask to solve the general problem, it may draw the wrong conclusion. But if you split that into simpler tasks, then each one of them is more likely that it can get it right. And you see here that when I ask things step by step, is doing a kind of breakdown and then is getting the right answer. So this is chain of thoughts. And of course, you can combine techniques, right? You can combine chain of thought with a few shots, like here. So I can say, well, I have a question here. My brother was 2 years old, and then I showed the answer. And then I have a question, and then I ask the answer. Okay? So not only step by step, but also I can show with another example what I expect. Okay, another one is self-consistency. What is the meaning of that? It's basically majority voting. It means you take the same prompt with usually higher temperature because you want a little more randomness. And then you ask the same prompt a few times, and then you collect the answer that is more common. So remember the review, positive, negative, neutral. If I ask the same question 10 times and I see that 70% of the times it's saying positive, then I'm more confident that it's positive. Next one is step back. Step back means you go from a general to a specific question. So in this example, I asked the LLM to write a storyline for a video game, right? Challenging, engaging, and you get something, but maybe it's not precise enough. Maybe it's not what we want. We want something a little more concrete. So what can you do? Well, first you step back and you ask a more, I would say, a question that is more specific. So say, okay, based on the games that you know, give me 5 possible settings for a video game. Now it's choosing 5. Right? So it's not a general question, create a story for a video game. I'm asking to create the setting for possible video games. And now that I have this answer, I can say, okay, now you have these 5, take one of them and make the story. And now it's way more concrete because it's related to a specific context. Okay? So step back again is when you have a general question, you try to ask a clarifying question first that will give you more context to go more deep and more to get a more detailed answer. Then, as I mentioned, context is another technique. The context is to define the setting of your interaction. So in this example, for example, you are saying, well, you are writing a blog for retro 80s arcade video games. So you set that context. This is the situation. Then after this, I ask the question, suggest 3 topics to write an article. So if I didn't set the context, I would not have had answers that were so specific. Because remember, The LLM is trained with a huge amount of material. Okay, so it knows virtually everything. If you ask a generic question, it will be very hard for an LLM to know which kind of angle to take. But when you set the context, you are saying, okay, now I don't care you answering like an expert in medicine, an expert in engineering. No, now I want you to consider the context where we are writing a blog about retro 80s arcade video game. Next one is called role. And by the way, I will share the slide with you at the end, so no need to take notes. You will have them later. So the role means you ask the LLM to act as someone or something. So in this case, you are asking the LLM to act as a travel guide, right? And then you are asking some kind of suggestion to visit Amsterdam. So remember, just because you ask the LLM suggestion to visit a city, you cannot assume that the LLM is answering as if it was an expert in that. You need to make it clear that you want that kind of angle. Okay, so I want to repeat again, never assume that what you have in mind is automatically known to the LLM. We are not yet there. So at this point, I want to summarize this with the best practices, okay? You have seen the prompts, you have seen the techniques. However, this is something else that you can consider when you are writing a prompt. Number one is provide examples, the few shots we have seen before. The other one is to be simple but clear. So be direct when you ask. Don't put a lot of description and things that are making the prompt longer for no reason. So you see here an example of a more simplified way to ask a question. Still, clarity is important, but don't overcomplicate things for no reason. Next one is to use verbs that describe actions, right? So if you have a very long text and you want the LLM to summarize, use the word summarize. It seems that LLM works better when you use verbs that directly describe the action that the LLM must take to answer to your question. The other one is to be specific on the output that you want. So see, the first question here, actually the second one, was generate a blog post about video game console. Very generic. You don't know how it will be done. But if you say generate a 3-paragraph blog about the top 5 video games, then you're giving more precise instruction. If I want the LLM to generate for me an Excel file with 10 columns and 5 rows, say that. Don't think, oh, it will figure out. I mean, maybe it will, or maybe we spend a lot of time with subsequent prompt to explain what you could have explained from the beginning. Right? Remember the picture example. The table is aligned with the monitor on the left. If you don't say that, no way you can know. So if you feel that you are giving too many details, I think it's better to give more details rather than having a generic thing that is not really clear or can be understood in different ways. Especially if you have numerical parameters like 3, 5. This is also quite good. Another one very important is much better to say what to do or what you want rather what to avoid. So here you have an example where in the second example, the prompt includes do not list video game names. In the first one is say, okay, only do this. And why is that more important? I give you a simple example. Imagine you are at the airport and you take a taxi, right? If you want to go to your house, you tell the taxi driver, hey, I want you to bring me there. You don't tell the taxi driver, I don't want to go to the hospital, I don't want to go to the city center, I don't want to go to the beach, right? So you don't have to say what you don't want, rather say exactly what you want. And then finally, my suggestion is to be flexible and experiment with different methods. If you want, you can also do something. You can ask the LLM to generate the best prompt for the LLM to answer to your query. This is also quite interesting. Right? So you're using the LLM to help you interact with the LLM. But the main point is that you have seen now a number of techniques that you can combine and use, and I cannot tell you which one is better. Depending on the task, one may be more useful than another one. Or maybe a combination can be more effective than using something else. So the best way is really to experiment and put together, try, and see what is the result you get. Okay, so I think that's more or less the end, and we are in the last part, the summary. I think today, maybe you have not realized, but you learn a lot, because you learn why prompt engineering and communication is so important. You have seen the example. I hope that you will remember next time you speak with someone or something like an LLM, you remember the pictures that you draw. And if there is some misunderstanding, maybe this will help you realize that, hey, maybe is the way I express my question. Maybe I should give more context. Maybe I should be more clear. Then you've seen the LLM. What is an LLM? A prediction engine. Some of the parameters, temperature, top K, top P, how this can change the way the output is generated. And then some more specific techniques. You've seen the 0-1 few shot when you provide examples, the chain of thought, think step by step, right? The self-consistency, when you have the majority voting, you ask the same thing a few times and you take the result with the highest number of occurrences. And then the step back when you go from a general to a specific thing, and then you use that to get a more detailed answer. The context and the role that you can set to tell the LLM how it should behave. And then you have seen a list of best practices. And to conclude, I also have a bonus question. Maybe you heard about that when interacting with LLM, many people at the end say thank you, right? And because every time you generate an answer, there is a cost behind. So Sam Altman from ChatGPT was sharing that this thank you or please at the end is costing a lot of money. So should you do that? Well, no, maybe because it's costly, but there is another interesting article in, it was published on, put on archive in last year. And then they did a study and it seems that being rude with LLM somehow improve accuracy. I think they tested with GPT-4, if I'm not wrong, and then they have seen an increase of around 4% of accuracy. But some people think that one day LLM and AI will take over, so they may remember if you were kind with them. So up to you. Maybe it's good to say thank you once in a while. That's it. So if you want to explore more, I have one thing to share with you is this white paper from Google, where you see many of these techniques and examples, and it's free. And then the other one, if you want to explore what we discussed at the beginning about communication, the meta model, you remember the deletion, distortion, generalization, you can have a look online, the meta model by Virginia Satir. Or maybe now after this course, you can even ask questions to your LLM, GPT, Gemini, whatever it is about this topic. Now you know how to do it, so you should get the information that you want. with this, I thank you, and that's it. If you have any question, feel free to ask.
Thank you, Alberto. We maybe if you have 5, 10 more minutes, we can see if there are any questions from the group.
Yes.
But I really, really enjoy your class, Alberto.
Hope so. I hope they join the drawing also.
Anyone has any questions for Alberto?
So by the way, as I share, I can maybe later, Giacomo, send you the slides, and so they will find a reference of all the techniques, and maybe this is useful.
Yeah, we'll upload on Canvas the slides as soon as I receive them.
Okay.
I guess a quick question, not actually for you, Alberto, but in general, how many of you is interacting daily with Gemini, ChatGPT?
So for me, I'm using quite a lot for two reasons. One is for research, sometimes brainstorming, and I think GPT, the last one, is very good. If you know your topic, it may point to something that you didn't know from other fields that can give you insights. But the other way I'm interacting is with agentic AI. I'm developing some software to do a little more complex tasks. So agentic AI, if you don't know, is this way to create tools and software that can solve specific tasks, right? And then the LLM usually is used to decide what to do. So maybe you have functions that are doing something that you code, and then based on the question, you need someone to decide which function to call, how to combine the output, and how to proceed. And this is something you can do with agentic AI. So it's also quite good. And I've seen the last model of Google, the Gemini, is very powerful for that.
See, Frank has raised his hand.
Yeah, just kind of going, if you're as kind of general, like I've started using it the last few weeks more on the personal side, just more honestly because I realized that we had gotten a subscription back in September, and I was like, well, I better start putting some use to this. And then also at work too, they're starting to do in the army, putting in more and more to he start utilizing it. They have their own like military side structured one, just to help with kind of the day-to-day planning, kind of like training planning and kind of simplify some of the stuff that's a little bit more we tend to make complex.
Got it. I guess a lot of companies are also kind of almost forcing their employees to use AI.
You say forcing, I say sometimes replacing, but maybe that's another discussion. But you're right. I mean, if you are not using, you have an handicap, right? Because people who can use this can be more productive, can be faster. Of course, you don't want to replace your critical thinking. That's, I think, the main risk. You don't want to delegate your thinking to AI and just copy paste. It's something that unfortunately is happening often now at universities with students. There are professors complaining that they do homework and they don't know if the student did anything or just copy paste the answer. But I think it's scary because in this case, you're not using AI to augment in a way your abilities, but the opposite. But yes, I think for many tasks now you can be much faster writing code, generating pictures, generating summaries. This is something where you save a lot of time.